Hello, everyone. I'm Julien, so I'm principal engineer at Datadog. Today, I'm going to talk about data observability and OpenLineage. So imagine we're working at Canoe. So any similarities with an existing company is purely a coincidence. And the key feature of Canoe is recommendation. Not only can you search for a great vacation, it's going to recommend to you a great vacation in somewhere sunny and nice. However, today, for some reason, the recommendations are wrong. Like instead of having the nice, dreamy destination for your vacation, you end up with some crumbly location that you're kind of worried like bats are going to come out of. And to be clear, also, no animals have been hurt in the making of this presentation. So, recommendation is wrong. And as any data ecosystem in any company, at Canoe, the data ecosystem can be a bit complicated. There are lots of teams producing and consuming data. And they're very aware of what's happening in their own little bubble, of how they consume data, what their best practices are, and so on. However, sometimes it's a bit hard to know where the data is coming from, right? You're reading from this table or from those files somewhere in blob storage, and you're not quite sure who updates them, how often they're updated, where they're coming from, and it's kind of a bit opaque. And what happens if something's broken somewhere, since everything's automated, like the brokenness and the wrong data like propagates through everything. And if you get the wrong data in, you probably produce the wrong thing out, and suddenly everything's broken. Right? Maybe you didn't touch anything to your recommendation job, but for some reason today it's producing the wrong results. And the conclusion is you get from the great recommendation that everybody loves and bring the users back to your website to the thing that's wrong, and everybody says, like, what is this? Why am I even here? Let's get back to something else. I don't want to be in the bats. And so, like, the first thing you do, how do we investigate this? But so everything's opaque, right? I'm not quite sure where it's coming from. This isn't like our system works. I don't know where it's coming from. Someone else, something is broken. I don't know where. It's hard to investigate. And usually, you end up in a situation when everything goes right, everything works, but as soon as something is wrong, it's going to take weeks to figure out the root cause of the problem. And you don't have that luxury. You don't have the time. And what doesn't help is the whole ecosystem is very fragmented, right? Like every team might be using different tools, right? Like there are tools that's more specialized for analytics, for ETL, for machine learning, and a bunch of different things. And depending on the case, you're using a different tool. And they all speak a different language for understanding what's happening, right? Like whoever has been frustrated at not having the right connector, right? Like all of those things, they mostly send the same current, but they all do this through a different standard. And so what we do need is a common language to represent how data is transferred, to understand lineage between different data transformation, where data is coming from, where it's going, how it changes, who owns it, at what frequency, and so on. And as we know, finding a new standard for everything is difficult. Right? Like this famous XKCD, what? We have 14 standards. It's easy enough. I'm just going to think hard about it and find the one standard that encompasses everything. And what happens, soon we have 15 competing standards. Because the thing with the standard, it's not about finding the spec that's going to work for everyone, right? Like if you think of these power outlets, they all work, right? It's not that we need a design that does all the features they all have. They all have the same feature. However, they do it all in a slightly different way. And the way you avoid this, it starts with people, right? To get a standard, you need to start talking to people and agree that we're going to get together and do it the same way, right? It's not like someone is thinking only a subset of the problem. It's just like we're all thinking about it in slightly different way. So you start with people, and all you need to do is a few trailblazers who can help start figuring out how we standardize lineage. And I like using this image about the stone soup. So if you know this children's story about the stone soup, the story is there's some person that comes to a town square, and they start setting up, they start a fire, they put a pot on top of it, they fill it with water, and they start heating the water, right, and stirring the pot. And when people come to that person and say, what are you doing? Well, I'm making a stone soup. And the image of the stone at the bottom of the pot is just that the stone has no flavor, right? So it's a soup at nothing. However, this person can say, hey, I'm making a stone soup, but you're welcome to contribute any ingredient to it that you like. And maybe someone comes with carrots and someone else comes with leek, and we're all putting in it, and we're all making it better for everyone, and we're all going to share. And so building a standard like this, it's often just that, right? You're just creating the opportunity for people to collaborate and build something together, and all I'm doing is really just stirring the pot and making it possible. And there's really a network effect on aligning incentives, right? Like if you can explain how we all benefit from the standard, right? You're not going to contribute to my standard, right? We're just going to build this together. And the more people use it and contribute to it, the more it becomes valuable for everyone, right? So that really creates a snowball effect where the more you build momentum around the standard and the project, the more there's an incentive for other people to join, right? Because every time there's more things in that ecosystem, the more it becomes valuable, because the standard is only valuable if it's been adopted by enough people. So there's really this accrual of momentum that happens. So now I'm going to talk about OpenLineage, because the thing I've been hinting at is the creation of OpenLineage a few years ago that led to the standardization now of how we collect lineage for this whole ecosystem. So traditionally, we had 3 different ways to observe lineage, right? And the first way is by doing more static analysis, right? You can look at your code repository, analyze the source code, and understand, maybe you're parsing the SQL queries, maybe you're looking at your data frame transformation, and you can understand how the output data is derived from the input data, where you could understand at the column level how it's derived from the input. And the downside of this approach usually is you don't know what's actually deployed in production, and you may not know actually what databases it's connecting to, right? So there's some of the metadata that's missing. You have some nice information of how the data is transformed. You don't really have the information of how to connect it to physical data sets. So it kind of has some holes in it. Another approach has been using existing query logs, right? If you have a data warehouse, and that's the main way people query, consume, create derived data sets using create table as or things like that. You can look at the query log and you know everything that has been happening, right? And traditional way of doing this, you can parse all the SQL queries and you understand how each table is derived from another. Downside of this approach is you lose a lot of information because it's after the fact. It's not necessarily being collected, understanding where the queries are coming from. You may not connect is this an ad hoc query? Is this something that's recurring every hour or every day? Is it part of an ETL? Is it part of some transformation to model data? There's a lot of information that's being lost in the process. So you have a fairly accurate view of everything that happens in the warehouse, not too much what happens upstream of it, downstream of it, or in other environments. And so it also adds some gaps. The third way to do this is to observe the pipelines as they're running. And, spoiler alert, that's kind of the OpenLineage approach, right? We integrate with the data orchestration systems, and as the job runs, right, you can instrument the job and observe what's currently happening and get a lot of metadata that's related to what's happening at the moment. And because the job is running, that's where all the metadata information about this particular job is available. And so if you can collect it, you can then centralize the collection of it and infer lineage. So to give a little example, right, if you look at the picture you took, you can look for the metadata after the fact, right? If it's a picture of the sunset, you can infer, oh, look, it's the sunset, it was taken about at this time, it's facing west, there's like probably this location. there's something you can infer after the fact, but it's never going to be as accurate as the information that the camera, if you instrument it, can collect, right? Like modern digital cameras, we capture longitude, latitude, time it's taken, metadata about what lens you used, and things like that. And it's going to be way more accurate than using something that's not designed for extracting metadata and that has been saved and use it after the fact. So instrumentation is really important aspect. And so you could say that OpenLineage is the EXIF data for data. So if I look at OpenLineage, it's made of 3 things. One, it's a spec. It's an open spec that explains how you describe lineage and related metadata, like it could be data quality metrics. It could be schema, it could be a lot of other metadata around this data. It could be query profiles. Second, it's libraries to make it easy to integrate in various different languages. And last, there's a list of integration with the most popular open source data frameworks. And so before, the way lineage consumption would happen, you would have a lot of lineage consumers, like maybe data catalog, maybe they worry about compliance, maybe they worry about data reliability. And you have this common quadratic problem of all the consumers need to talk to all the producers, and there's lots of reverse engineering happening, right? All the various producers have some notion of lineage, but it's usually all very specific. Sometimes it's not even public API, so there's lots of reverse engineering looking into the internal of the systems to extract the information and see what's happening. So that creates a lot of complexity and a lot of brittleness, because it's all relying on internals. Whenever something changes, it can break the integration. So this just creates a lot of work to keep creating and maintaining the integration with that. So if we can define a standard, like we get rid of the quadratic complexity, and we can get to a much simpler situation that it's more linear growth with the ecosystem of how much work it is. Because each new producer of lineage, whether could be Spark or Airflow or dbt or any other things that transforms data, can just comply with producing their lineage metadata in a standard way, and all the consumers can just consume in that standard format. It makes it a lot easier. Since now we have an explicit contract, it's a lot more stable. People don't break the lineage definition willingly, and it's a lot easier to scale the whole ecosystem. So that's where the more people use it, the more people benefit, because any new producer that uses it, all the consumers benefit. Any new consumer that uses it, you get visibility in all the producers. So there's really like this snowball effect that builds from that. So being in observability conference, right? Like I'm assuming a lot of you are familiar with OpenTelemetry. I'm going to talk a little bit about the parallel between OpenLineage and OpenTelemetry. So if you think, like, OpenTelemetry is a project led in a CNCF, which is a sub-foundation of the Linux Foundation. It's a collection of tools, APIs, and SDK, right? And it lives in that ecosystem. So if you think of OpenLineage, it is the same thing, right? So OpenLineage is part of the LFAI and Data Foundation, which is a sister foundation of the CNCF. It's part of the Linux Foundation family of foundations. And it is also providing the same functionality, but for lineage, for data pipelines, instead of telemetry for services. And if you think about it, there's a lot of similarity between lineage and traces. However, they work slightly differently, right? So there are lots of concepts that are similar, but because data pipelines work in a different way than services and traces, we do have to define a different standard on how to represent things. If you think about it, right, when we think about traces and services calling other services, you always have a tree of dependencies, right? The request common first service, and you see those spans are contained within the main span, right? Like first service is called, we're going to call another service, the service B, and then service B calls the service C. When C returns, B calls the next service D, and then when it returns, it goes back to A that can call the next service, right? So we follow this tree with the depths first and going through this. The first service is aware of its downstream dependencies because it's calling them synchronously. Now, if we think of lineage, it's slightly different, right? When a job produces a data set, it is not aware of the downstream consumers. You always have an indirection between jobs and data sets, right? A job writes to a data set and another job reads from it. It reads from it, and it also doesn't necessarily read from it at the same granularity, right? You could have an hourly jobs or daily jobs. They may not be in sync. And there's always this indirection between the two. So the job A finishes, and then job B and E will happen later on, and the job A is not even aware of it, right? So you have, it's not a tree anymore, right? It's different type of interaction, and that is why the lineage model is different, right? Because we capture metadata in a very different way, where there's not correlation ID that propagates down the call stack. There's no call stack in this case. But when we think about it, it's useful to draw the parallels because they are very similar contract concepts that we can use. So on the services, you will have service APIs as contract. On the data, it's the dataset schemas. When you look at distributed traces for services, it's similar to data lineage and how we connect dependencies between the various transformations. And in services, SLOs are thought about as availability, latency. In data, it's freshness and data quality. Freshness is, has my data set been updated in time compared to the last time the upstreams was modified? And data quality is the actual data correct, or do I have errors in my data? And so going down in more details on how OpenLineage works, it starts with a simple model of 3 core concepts. You have the job. The job is this thing that is recurring, right? A job will run multiple times a day, but the run is each instance of the job running. So you will have a job that has a unique identifier that identifies the recurring job, right? That might be running every hour. And it reads and writes to data sets. Data sets are also identified with a unique identifier, right? The key, one of the key elements of the OpenLineage spec is standardizing how we identify data sets across data transformation framework in a way that we can reconnect and stitch the lineage back together. And so on each of those entities, you can attach facets. Each facet is a atomic element, piece of metadata that's defined by a JSON schema that attached to one of these entities. So to give you examples, a data set might have a facet about the schema of the data set, right? It could be, if it's a table, it could have a schema. If it's a Kafka topic, it might have a different types of facets attached to it. On the run, you might have the query profile attached as a facet, and so you can understand better performance or cost of various runs of a job. On the job, you may have the query plan or some information that may vary depending if it's a Flink job or a SQL query or a Spark job. And all of this is connected in a run event. The run event is the thing that ties all things together, right? If you think of the life cycle of the job, we'll start with a start event when the job starts. So if you think of a batch process, you will have a start event that gives metadata about the job. Where is it reading from? Where is it writing to? And then the main other events there will be is the complete event when the job is complete, and that we know it's finished running and when it's finished running. If it's a streaming job, you will have the same thing, but since you don't really know when it's going to complete, you often have running events in the middle that show progress of the jobs. For example, in the Flink integration, we're going to send a running event every time there's a checkpoint. And if you're worried about having too many events, you can also cap the number of running events. Sometimes people checkpoint very often, and therefore they may not be interested in having an event every time this happens. And of course, if the job fails or is aborted, you get a different event than the complete event. And to give you a quick example of what that looks like, OpenLineage is defined as JSON event. We have JSON schema for the core spec as well for each of the single facets. So if we zoom in, the first section here is the definition of a run, and you'll see in particular we have the parent run of what triggered this particular run. So if you think of, for example, an Airflow job having a task that starts a Spark job, you will have the Spark job will connect up to the run that triggered it in Airflow, right? So that's how we connect nested jobs, like you may have an Airflow run that runs a Spark run, and they're connected together in the metadata. At the job level, you may have some facet. For example, if you have a comment description of the jobs in your Airflow task built in your code, this can carry over as a facet. So in your observability side of things, you know what this thing is. You will have inputs. The input data sets here shows, for example, the schema at the time of reading, so that from one run to the next, you can see whether the schema has changed, and that may have caused a problem you see in your job. In the output here, we're collecting metadata about the output. In this case, we're capturing output statistics. For example, when you run a Spark job, Spark collects statistics on how many rows were written to this table, and you can keep track of this. So for each run, you know you can have like simple statistics on how many rows were written by this particular run, and that can be an indicator later for troubleshooting things. And since we standardized how data sets are identified, you can stitch lineage together and understand the data flow end to end. And so to finish, I'm going to go a little bit more in how that looks like, how Datadog leverages OpenLineage to improve its product and makes your life easier in troubleshooting things. So if we get back to remember how suddenly our website got haunted by bad data and bad recommendations. So how do we get there? How do we fix it? So everything was broken. Something was broken somewhere. And since we don't know what happens, propagated everywhere, we don't know how to troubleshoot. Now, if we have lineage, what we can do is walk backwards this graph of dependencies. Now we can understand it better and see where the problems is coming from, right? So, oh, wait a minute. Now I'm not like, well, I didn't touch anything. I don't know where the data is coming from. I don't know what's broken. I can actually just go in the tool and walk back and find, oh, wait a minute. This has changed. This has changed. This is not like before. We can actually find the team is like, instead of being, I don't know, ask this other team, we can go see the team and say, oh, hey, I noticed this. This looks funny. Can we work together on solving this, right? And now, because you see what's happening, everything is easier to resolve, and there's a little bit less of throwing the rock over the wall. And, I don't know. Because you can start, so this is the job view, and you can say, hey, this is my recommendation job. Look, it's been running the way it's always been running. Everything looks fine. Everything's green. This is fishy. What's happening? Let's look upstream, right? So I can go to the lineage page and see, oh, wait a minute. So I'm depending from this table, and I can keep going upstream and see what happened. I can mouse over things. There's like something as an alert. I can start looking at the data quality metrics. Like, are we having fewer rows than before? Are there more errors than usual in this data quality check and so on? And then I can go deeper, right? This is an example of having an Airflow job launching a Spark job or multiple Spark jobs, right? So the green lines, the green spans in this graph are the Airflow jobs, and all the colored ones are individual Spark jobs that have been triggered by it. And because things are connected across those frameworks, I can actually see, oh, look, this Airflow job triggers a Spark job. If there's any problem that's related to things being slower than usual, I can investigate more, right? I can look the historical runs and understand why this thing is slower than it used to be. Because we connect traces and lineage, right? We have the trace instrumentation in Spark, and we have the lineage instrumentation in Spark and in Airflow. We can actually look at what's happening across those frameworks and understand better where things are happening. This is especially useful if something is suddenly much slower. You can dig deeply into, oh, what? Wait a minute. Now I understand what the time is spent, and I can see the frame graph across everything. And by the way, that works as well for a dbt model. You can get the same view because they're all integrated in the same way, and you have this abstraction of jobs and dataset and lineage. You can actually understand, dig deep, and understand what things are happening. And so now, well, wait a minute, we got back to our website being fixed. And we were able to do this, having constructive conversation between different teams and not like, throwing our arms in the air and say like, I don't know, it's so hard to troubleshoot everything. And actually, there are lots of possibilities, right? Like, we've been talking about the data reliability and troubleshooting use case. But one thing you can do is, since you understand your dependencies, maybe you can prevent problems to happen in the first place, right? Of course, you can use lineage to walk upstream and figure out what caused the problem, but you can use it to look at the other way and do an impact analysis, right? Like before you push something into production or like you push your change, you can actually check who you possibly are going to impact, and maybe if you communicate about pushing your change, instead of sending an email to the whole company that nobody's going to read, you can contact directly the teams that are going to be impacted. Hey, watch out, we're doing this change tomorrow. You might want to look out for what happens, right? Or I can just know that it's not going to break anything. Also, a bunch of use cases for regulations. If you want to be compliant, there's tons of reasons why you would need to know lineage, or just knowing where your user private data is going, and it's going only in the places that it's supposed to be going, and avoid having fines because you don't watch out where your user private data is going. So how does this benefit you, right? You get clear, unified, cross-platform lineage. It's easier to debug and trust the accuracy of your data. And an open standard ensures it's going to work consistently everywhere, right? Like it's only going to keep growing and have more visibility into it. And concretely, if you're interested in investigating in this, I would recommend first identify your key data sets and jobs, and start from there and look upstream, right? Sometimes getting lineage feels like boiling the ocean. Start with the things you care about, right? You don't need 100% lineage. You need 100% lineage on the things you care about, right? So focus on those first. And there's tons of instrumentation in OpenLineage, whether it's Airflow, Spark, dbt, Flink, also proprietary ones. It's also been adopted by the 3 main cloud providers. And thanks to combining traces and lineage, you can achieve a lot. Thank you. If you want more information, you have all the contact information for the OpenLineage project. And you can get the main way of communication is often the Slack. You'll find an invite link on the website. And if you want to learn more about the data observability features at Datadog, this is the documentation. Just Google Datadog data observability. And on that, I can take a few questions.
Thank you very much. You can now send the event complete to the run. We have some mics in either aisle, so if you have questions, please come up to a microphone. You've got Julian's undivided attention. I don't see any people just yet, but I know that they will get there. There's a microphone right there. Yeah.
Yeah, and I can't see you with the lights, so just
we
speak
really
up.
Can't see anything. Oh, no. All right, somebody's going to the mic, maybe?
Or they're trying to... No,
yeah, go ahead. You've got a race condition.
So I had a question on the OpenLineage and the integrations for it. Is it purely limited to ETL tooling, or if we wanted to integrate it within whatever like services generated the data, like the backend services, cloud functions, etc., would it be able to integrate into those components as well?
Yeah, it's going to integrate with whatever emits OpenLineage. So sometimes people even build their own custom OpenLineage events. So since it's JSON, if you have like, because if you're using Spark or Airflow or dbt, all those things have built-in integrations, right? If you build your own thing, you can create your own OpenLineage events. Sometimes people, they write their own OpenLineage events for a custom job that's just a process you've written in some language and you're reading files or writing to tables directly and there's no integration for it. You can do it. Or anything that has an integration, right? It's really open to anything that transforms data, really.
And are there like open source libraries to run those integrations, or is it just like a standard that we'd have to follow?
So you can either directly generate JSON, and you send JSON by sending a post over HTTP, for example, or there are also libraries in the most common languages, Java, Python, Go, to produce events as well.
Thank you.
You're welcome.
I was wondering if the standard addresses consumption of data from the front end and all the way through microservices to the actual final data sources.
So there's still, so that's one potentiality, right? So if you have, let's say you use a RUM from Datadog, and then you're using APM, and you have traces, and then you have lineage, eventually we'll connect everything. So we're not, I think the product doesn't quite have everything connected, but one day it will have connect everything, but you can start seeing what's happening on the service side, right? And then maybe from there you write to Kafka, and then from there you dump this into buckets, or you put it into your warehouse in a table. And then from there you have dbt jobs transforming the data. So I don't think we have quite features yet that connects everything. We do have all the data, and you have views for the service side of things, and you have views for the data observability side of things. And one day we'll have like connected everything together so you can follow the flow. But that's definitely in the works.
If you want to learn more about data pipelines and tracking them, stick around for the next talk right here.
Oh yeah, the next talk is going to talk a lot about data quality and all the related problems.
One more?
Yeah, one more. Just, is there any collaboration with OTel around ingesting and transporting the OpenLineage events into a storage system?
There's been like several conversations in the community. I had given a talk a while ago at a meetup, like talking about OpenTelemetry and OpenLineage, and there's been discussion in the community on how to connect both together like better. Because the data world is often like pool-based, right? It takes the data from the data set and writes, and when the service world is more push-based, you have to reconnect, and how we connect the dots and making them work together. So there's still work in progress, but it's definitely something like we're looking more. And because we get all the data in one place, we are definitely incentivized to make the connection work better. And I see Jonathan over there. If you have questions, this guy with the cap, you can ask him more questions about what the product will do.
Thank you so much, Julien.
Thank you.
Good talk.